In this first section, we're going to be looking at naming these organic compounds or organic molecules and looking at the various different functional groups that will give these organic compounds their sort of chemical property. Okay, so the first bit is firstly looking at what an organic compound is. So an organic compound is any compound that contains carbon. Okay, so all the molecules that we look at in this, pretty much this whole topic, are going to have a carbon, at least a carbon molecule in them. And more interestingly, they're going to have what we call a carbon backbone. So everything's going to come off a sort of base carbon chain. And the most simple sort of organic compound that you might see is what we call an alkane, which we'll look at in a sec, which is essentially a backbone of, say, for example, 5 carbons, and then you have hydrogens attached. Okay? And this is probably the most simple organic compound that you might come across. Okay? And this molecule here, out of interest, is called pentane. Okay? But anytime we have a molecule that contains carbon, we call that an organic compound. And that's because anything that naturally occurs pretty much will have some sort of carbon in them. Okay, so that's what we're going to be looking at in this, pretty much this entire topic. So anything containing carbon, we call an organic compound. So later in this section, we're going to be discussing functional groups. And functional groups is anything attached to this sort of carbon backbone. So we said organic compounds contain carbon. It's generally a carbon backbone. And functional groups are anything that are attached to that carbon backbone. So for example, they could be single molecules or a single atom. For example, having a chloride attached or a bromide attached, and we'll discuss all of these in detail later on in this section. Or we could have a group of atoms, okay? So you could have a hydroxide attached, or you can have like an amine group attached, so NH2 attached, all right? So these functional groups are really, really cool because they actually give this carbon backbone or the organic compound its chemical properties. So it's kind of like wearing a boring outfit and then having like cool accessories to spice things up, right? These functional groups will make this boring carbon chain have sort of unique chemical properties, all right? And then if we look at isomers, and again, we'll discuss this in a bit more detail later on in the section. Isomers, if we think back to year 11, which we briefly discussed, it's any time that there's the same number of molecules, but arranged in different ways. So same number of molecules, and also the type of molecules, but it's a different structure. Okay? And there are lots and lots of different isomers that we can talk about. And there's about 3 that we need to cover in the syllabus that we'll talk about a bit later on. Okay? So this next page is covering those 3 types of isomers, but we might come back to this once we've talked about the different functional groups and even just firstly looking at different types of organic compounds that can actually exist. Okay? Well, the first type of organic compounds that we'll look at are called hydrocarbons. And as the name suggests, hydrocarbon means they contain hydrogens and carbons. Okay, there will be other things that are attached onto that, but a majority of these molecules are going to be carbon and hydrogen. Okay, and instead of looking at every single different type of organic molecule that we can get, because that would be impossible to do because too many of them, we group them into what we call homologous series. So what homologous series are, they're any group of compounds or molecules that have similar structure, similar chemical properties, and have the same general formula. Okay? So they're essentially, like, I like to think of them as almost like a family of molecules, right? So the first family we'll talk about is alkanes, okay? And so how we know it's an alkane, like families who share the same last name, all alkanes will share the same last name, and they all end in anes, okay? So alkanes all end in A-N-E, and they have this general formula CnH2n+2, which means, so carbon, it will be, if it's 1 carbon, it will be CH4. If it's 2 carbons, it'll be C2H6, 3 carbons, C3H8, etc. Okay? So that's the general formula for alkanes. Now, what firstly is an alkane? Well, if I draw this molecule out, and I'm actually going to draw it next to these prefixes because we'll talk about those in a sec, but I might have CH4, which looks like that. So carbon, 4 hydrogens, like so, right? Or I might have C2H6, which looks like this, okay? Or I might have C2H6, which looks something like this, yeah? And so these are what sort of alkanes look like. They're a carbon bonded to only hydrogens. And here it says it's a saturated molecule. And the reason why it's a saturated molecule is if you have a look at this carbon here and these hydrogens, how many bonds can carbon at maximum form? Well, 4. And if you look, it's formed 4 bonds. How many bonds, covalent bonds, can hydrogen form? Well, at most 1. Okay, so here, if we look at all the hydrogens and all the carbons, they are saturated. They have as many covalent bonds as they can possibly have. And that's why we call them saturated molecules. And we'll come to unsaturated molecules in a sec. Okay, so how do we name alkanes? Well, we take the prefix, and the prefix always represents the number of carbons. Okay, and this doesn't just apply to alkanes, it applies to everything that we'll talk about in this section, where if you look at the number of carbons, you take the prefix. So if it's 1 carbon, it's meth, 2 carbons, it's eth, 3 carbons, it's prop, 4 carbons, but, etc., etc. We go up to 8, but you can continually go on. So 9 would be non, 10 would be dec, 12 would be dodec, for example. So the prefixes are very similar to like our Roman numeral prefixes. But this molecule here, because it's 1 carbon and it's saturated, all it is hydrogen. So this is CH4. That would be called methane. Okay. And then this molecule here, because it's 2 carbons, would be called ethane, for example. Okay. So something like, I don't know, octane down here. 1, 2, 3, 4, 5, 6, 7, 8. And I'm not going to draw all the hydrogens in, but all these dashes are connected to a hydrogen. And that's because there's 8 carbons, that would be called octane. Okay? And so that's how we name alkanes. So alkanes, the general things that you have to remember is that it's carbon bonded to hydrogens, and it follows this formula here. It is a saturated molecule, meaning all the carbons and all the hydrogens have the maximum number of covalent bonds they can form. And for alkanes, it's just carbons and hydrogens. And how we name them, we look at the carbon chain, and then we include the prefix, and then we add the last name, which is ane. Okay, so methane, ethane, octane, for example. Okay, so that's alkanes. Now there are isomers of alkanes, and what isomers, like we talked about before, isomers, what did we say? Same number of molecules, but different structure. Now, we'll come back and talk about isomers in a bit more detail at a later stage, but I'm just going to draw the molecule down here because it ties in with talking about alkyl groups. But you might have a molecule like this. And so I won't draw the hydrogens in, but all these dashes attached to a hydrogen. So have a think about what this molecule might be named. And then you might have a molecule that looks like this. Now, this molecule here is called a butane, right? Because it's 4 carbons, butane. Now, the difference between this molecule here and this molecule here, and we'll talk about how we name this molecule in a sec, but the difference between this molecule and this molecule here is that it's a different structure now, right? Because it's not 4 carbons in a row, it's a 4 carbon and there's got this bit here. And it's sort of like almost like a branch. Instead of having like a nice smooth log, you have a twig with heaps and heaps of branches. Right, and here it's got 1 branch. And what we call this group, we actually call this group a functional group. Okay? It's a functional group. It's a branch off the main carbon chain. Okay? And the main carbon chain is this 3 carbon here. Okay? And so this bit is a functional group. And more specifically, it is an alkyl functional group. And what alkyl functional groups are is it's anything attached to the main carbon chain, because that's what functional groups are. They're things attached to the main carbon chain. Anything attached to the main carbon chain that resembles an alkane. That's why it's called an alkyl group. It resembles an alkane. And if we have a look at this thing here, right, what does it resemble? Well, it's carbon bonded to 3 hydrogens and then another carbon. So if I replace this with a hydrogen, it would look a little something like this molecule up here. And that's methane. right? So this is what we call an alkyl functional group, but more specifically, this is an methyl functional group or methyl alkyl group / alkyl group. Okay, this is a methyl group, all right? And if you count up all the carbons and all the hydrogens of both these molecules, they're actually the same, okay? So the formula for this is going to be C4H10, and the formula for this one is also going to be C4H10. And so that's why we call these two molecules isomers, because same formula, but different structure. And that's going to happen, especially when we get longer and longer carbon chains, because it's like thinking about finding a really, really long twig with no branches. As you get longer and longer, it's more and more difficult to not have branching. So you're going to get isomers forming quite commonly with alkanes, okay? Now, so we said naming alkanes, you look at the main carbon chain, okay? And then you look at the branching off the side, yeah? So we said when we name alkanes, you look at the number of carbons, and then you chuck the prefix, and because it's an alkane, everything's saturated, we add the last name ane, so it's called butane. Now, how do we name something like this when it's got a functional group? Well, when we've got a functional group, it becomes a little bit trickier, and we've got to name the functional group as well, all right? So how do we name this molecule here? Well, we start off by counting the longest carbon chain, and we'll have a formalized step-by-step process in a sec, but just as a brief overview or brief introduction, you look at the number of carbons, the longest number of carbons in a row. So if you count here, the longest number of carbons in a row is 3, okay? Because you can't sort of count the 3 and then go up there, right? It's a continuous chain. So the longest continuous chain is 3. How do we name a alkane that has 3 carbons? Well, that's called a propane, okay? So what we're saying is the base or the backbone is a propane alkane molecule. And then you've got this sort of alkyl group or this functional group attached. And how we said we name these functional groups, if it's 1 carbon, it's called methyl. Like so if it's 2 carbons, it's called ethyl group, 3 carbons, propyl group, etc. So it's a 1 carbon group. And so what that would be is called a methyl group. But this methyl group could attach here, could attach on the ends, for example. So we've got to number the position of this methyl group. And how we number the positions is we just number the carbons, okay? And you number the carbons such that this methyl group will have the lowest possible number. So you either number left to right or right to left. But in this case, it's going to be the same result, right? Because if we label this 1, 2, 3, it's in the second position, or it's on the second carbon. And if I named it the other way, 1, 2, 3, it's still on the second carbon as well. Okay, so how we name this functional group is we put it at the front and we say it's 2-methyl propane. Okay, and there shouldn't really be a space in between there. So essentially, this molecule here is called 2-methyl propane. Right, it's a propane backbone, and the methyl group is in the second position. Okay, and so that's how we go about naming alkyl groups, but we'll do more examples in a sec, okay? But to sort of summarize this alkyl group is any sort of functional group that looks like an alkane that's attached to the main carbon backbone or the main carbon chain. So this methyl group is attached to the main carbon chain. And then you could have things like ethyl groups. So ethyl groups is just a ethane that's attached. So this might be attached to the main carbon chain. So on this side, that might be attached to the main carbon chain, and you've got an ethyl group here, so 2 carbon. And then propyl, that's CH2, CH2, CH3, for example, right? And that's sort of attached to some random thing, right? So if you look CH2, that's, if I had to draw that out, that's CH2 bonded to another CH2 bonded to a CH3, okay? And this bit's the bit that's attaching onto something, right? So that's called a propyl group, okay? Now, there are a couple of more examples over the page. So if I just zoom out so we can see everything. Before we get to these examples, I might give you guys some examples to go off because these ones are a bit tricky. So let's do a couple first, but let's recap the main steps that we had to use. Okay, so the first step was to identify the longest continuous carbon chain, okay? Then it was to identify the alkyl side chains, all right, or any functional group. We've only learned one functional group, which is the alkyl functional group. In a sec, we'll look at other different types of functional groups. So you identify the alkyl groups, then you number the carbon so that these alkyl attachments have the lowest possible number, and then you name the isomer or you name the molecule. Okay, so if we have a look at something that's a bit easier than the ones that are above there. So if we have something like this, okay, so this molecule here, I won't draw in the hydrogens. If I have something like this molecule here versus, say, for example, this molecule here, right? And then I might give you guys one more and say, okay, this molecule here, carbon, carbon, like that, okay? And then actually we'll do one more variation. So we might have C, like that. So everything that doesn't have a carbon attached, all these sort of free lines, we just assume that there's hydrogen attached. I won't draw those in, okay? But let's have a look at these different molecules. So there's a lot of actual variation to this that's quite important. So if we have a look at this molecule here, okay, again, longest continuous carbon chain, we can either count across here or we can count sort of this L shape, sort of reverse L-shaped looking thing here. You'll get the same name, okay? But just for ease, we'll count across here and say this is our longest carbon chain. So the longest continuous carbon chain, 1, 2, 3, 4, 4 carbons. So what's that going to be? Well, it's going to be a butane, right? 4 carbons, everything saturated, so it's a butane. That's our butane carbon chain, all right? Or our butane backbone, okay? Now we identify the things that are attached. So what are the things that are attached? Well, there's only this additional thing that's attached. And there's 1 carbon attached, so it's a methyl group. So this is what we call a methyl group. Now we've got to number the carbons. Do we number left to right or right to left? Well, we want this to be in the lowest position possible. So if we number left to right, so 1, 2, 3, 4, it'd be in the 3rd position. But if you go right to left, it'd be 1, 2, 3, 4, 2nd position. So we number it right to left, okay? So it's in the 2nd position. So how do we name this? Well, then this becomes 2-methyl butane, okay? And it's really important it's 2-methyl, so anytime it's between a letter and a number, you always put a dash in. So that's 2-methyl butane, okay? Now, how do we name something like this? So if we look at the longest carbon chain, what I might do is I might extend this a little bit. So I might add another 2 carbons on it. Just so we don't have to worry, we won't worry about, for the time being, about like having the longest carbon chain actually turning a corner, for example. So just change up that molecule and add a few more carbons to the end, right? And so let's have a think about how do we name this molecule here. So if we look at the carbons, 1, 2, 3, 4, 5, 6, that's the longest carbon chain, having this 6 carbon here. So what's 6? Well, that's a hexane, okay? Now, here's where it gets a bit tricky, because if we look at what's attached, there's a carbon here, and then there's a group of carbons here, okay? So if we identify these functional groups, they're alkyl groups, but what do we call this alkyl group? This is an ethyl group, and then this is obviously a methyl group, okay? So how do we name this one? So we've identified the side chains, okay, or our functional groups as we would call them. Now we've got to number the carbons so that these two will have the lowest possible number. So do we go left to right or right to left? Well, we go left to right because then this will be position 2, position 3. If we go right to left, it'll be position 4 and position 5. So that's too big. We can get smaller than that. So left to right it is. So 1, 2, 3, 4, 5, 6. Now, so what we're saying is the methyl group is in the 2nd position, ethyl group is in the 3rd position. Okay? Now, which one do we put first, right? Because there's 2 of them. And when there's 2 of them, or 2 or more, we always do it in alphabetical order. So ethyl comes before methyl. So we do the ethyl group first. So what we say is it's 3-ethyl, so 3-ethyl, then 2-, I'll just move this hexane. It's 2-methylhexane, okay? So 3-ethyl, so what it's saying, in the 3rd carbon position, there's an ethyl group. In the 2nd carbon position, there's a methyl group, and it's a 6 carbon chain long, so hexane, okay? So that's what this means. So it's 3-ethyl-2-methyl. Ethyl in the 3rd position, methyl group in the 2nd position, okay? Now let's have a look at this one here, All right. So this one here, longest carbon chain is a 4 carbon, right? So that's the longest carbon chain, 4 carbon chain, right? So 4 carbon chain, that's a butane. Yeah. Now, our functional groups, there's one here and there's one here. And it's on the same carbon. And what's so interesting about this? Well, they're both methyl groups. Okay, so that's another methyl group. So how do we name a molecule like this? So same principles apply. So longest carbon chain, it's a butane. Now we want to number it so these are in the lowest position. So numbering it, do we go left to right or right to left? So we go right to left because that would put it in the second position. So 1, 2, 3, 4. So we're saying both these methyl groups are in the second position. So how do we let someone know that this is in the second position? So what we did before is we put a number to represent the position. And because there's two of them, we just put 2, 2. Then we put a dash. And instead of just saying methyl, because there's two methyl groups, we say 2-2 dimethyl butane. Okay, so this is 2, 2 dimethyl because it's 2 methyl and it's a butane backbone. Okay, so 2, 2 dimethyl butane. All right, so that's having functional groups on the same carbon. And if we have a look at this one, similar thing applies, right? So still 4 carbon backbone, so it's a butane. All right, now we've got functional groups here and here. Okay, and it doesn't matter if we label it left to right or right to left. In this case, it's still going to be position 2 and 3. So we'll just label it left to right. Okay, and now how do we label this? Well, if we looked back to this example, we did, okay, 3 ethyl, 2 methyl. So saying ethyl is in the third position, methyl is in the second position. So let's have a think about it. Can we write it as 3 methyl, 2 methyl? You can, although it gets a bit clunky because you're kind of repeating the same thing by saying like 3 methyl or 2 methyl, 3 methyl. You're saying the methyl group twice. So how we do it is we can combine it and we can say it's 2, 3 dimethyl butane. Okay, so what we're saying is it's in position 2 and in position 3 we have a methyl group attached to a butane backbone, and we say dimethyl because there's 2 methyl groups in total, right? So we say 2, 3 dimethyl butane, and that's how we label this molecule here. Okay, so to go over the main things again, if we have a look, main carbon chain. So the point of naming these molecules is so that if I give you the name, you know what the structure is. And if you give me the structure, I know how to name it, right? So it's kind of, it works in both ways, right? So you look at the main carbon chain, then you look at the alkyl groups combined, okay, or alkyl groups that come off the main carbon chain, or any functional group for that matter. Then you label it so that the functional group has the lowest possible carbon position. And once you know that, then you have a go at sort of naming it, okay? Now, let's have a look at these molecules up here, all right? So if we have a look at these molecules up here, let's have a go at the first one. So the first one, the longest carbon chain, quite obvious, is this sort of horizontal one here. So 1, 2, 3, 4, 5, 6. So this is the longest carbon chain. There's 6 carbons. So 6 carbons mean it's a hexane, all right? So it's going to be a hexane. All right, now we identify the things that come off the side. So there's one thing here and then one thing here. All right, so this is because it's 1 carbon, it's a methyl group, and because this one's 2 carbon, it's an ethyl group. So how do we name this? Well, we want to number it so it's in the lowest position possible. So do we go left to right or right to left? Well, we go left to right because it will put it in position 2 and 3. Whereas if we go right to left, it'll put it in position 4 and 5. Okay? So how do we name it? Well, we've got 2 alkyl groups. So again, alphabetical order, right? So the first one, we name the ethyl first. So if I'm naming it 1, 2, 3, 4, 5, 6, it will be 3 ethyl, 2 methyl, like that. Hexane. Okay, and I think that was actually the same. Yeah, it was actually the same as this molecule that we've done here. Okay, so it's 3 ethyl, 2 methyl hexane. Okay, and then if we have a look at this molecule here, now this molecule is a little bit tricky because your first instinct is, okay, this is the longest continuous carbon chain, right? Because if we go here, that's 4, that's too short because we can go longer. If we go here, 1, 2, 3, 4, 5, 6, 7. Okay, it could be 7 like that. Could also be 7 like that. But actually, there's a trick to it. because these covalent bonds, they can rotate. They're not in a fixed position. We can easily swap, these two can easily swap positions, and it wouldn't change the molecule. So if we look at the actual longest carbon chain, it's actually 1, 2, 3, 4, 5, 6, 7, 8, because that's still a continuous chain. Yeah. So actually, the longest carbon chain is this carbon chain here, and that's 8 carbons. So 8 carbons is an octane. And then if we have a look at the stuff attached, there's one here, right? So what are these? These are both methyl groups, right? And there's 2 of them. So how do we number it? Do we go right to left or left to right? Well, I think in this case, it doesn't matter, because if we go right to left, it's position 3 and 6. If we go left and right, it's position 3 and 6 as well. So it doesn't really matter. So in the end, we just write 3, 6. So let's just say we're leaving left to right. 5, 6, 7, 8. 3, 6. 3, 6. Dimethyl octane, like that. Okay. So just note that if there's more than one functional group of the same functional group, then you label it or you name it alphabetically. Okay? So if there's more than one functional group, you just name it alphabetically. Okay? Alright, so that's how you sort of name alkanes. There are things called cycloalkanes, and we'll talk about these sort of at a later stage when we talk about sort of more complex materials. But what a cycloalkane is, so we're used to seeing hexane as like 1, 2, 3, 4, 5, 6, like that, yeah? So cyclohexane looks like that, right? But we can also have cyclohexane. And what cyclohexane is, it's just literally carbons bonded together in the shape of a hexagon like that, okay? So that's why it's called cyclohexane. And if you draw in the hydrogens, well, there's 2 hydrogens attached to each carbon, okay? Because each carbon has to get to 4 hydrogens, right? So the formula for this would be C6H12, whereas this is C6H14, okay? So they're actually 2 different molecules, all right? And cycloalkanes, they have their own homologous series, okay? So alkanes is one family, cycloalkanes is actually another different family, okay? And cycloalkanes quite commonly are used in paint strippers, okay? So you see them sort of as like very potent materials, right? So they're generally used in paint strippers, and it has its own homologous series, okay? But we'll discuss cycloalkanes in a little bit more detail when we talk about sort of polymers at a later stage, okay?